So next example is Q233. Okay, a cylinder is to place in equilibrium between two layers of fluid. So now we further our problems if we have more than one liquid. So we have oil and water. Okay, the upper layer is filled with oil, so Sg 0.9. So if you know Sg 0.9 means the density is 900, and another layer is occupied with the water. If the height of the cylinder is 70 cm, remember if in the problems given any value, so but it doesn't shows in the figure, so better you put the value in the figure. Okay, so the height of the cylinder is 70 centimeter, and its specific weight gamma of the cylinder is, remember, gamma equal to rho g, so gamma equal to 9500 Newton per meter cube. So question asking to calculate H1 and H2. So what is the height of the cylinder in the oil part, and what is the height of the cylinder in the water? Okay, so now we know it's about buoyancy. So what to do? First, draw free body diagram. Okay, remember, first step is draw free body diagram. List all forces in vertical directions. So first we have only one object. We only have cylinder here, so means W downwards way to draw the W from center of the gravity, means the whole object, the center of gravity is the half of the 70 centimeters somewhere here, CG, so draw W. Okay, so now remember FB is about fluid. So now we have two fluid, oil and water, means we have two FB. Okay, because we have two layer of liquid, so we have two FB. If we have three liquid, means we have three FB. So where to draw the FB? So FB of oil, so because this, remember, if we want to draw the FB, means at the CB. So the CB is the centroid of the immersed parts in the fluid. So now in the oil, okay, oil, this is oil. This is only volume displaced in oil, means our CB is half from the H1. So our CB for oil is, so FB, if you try to draw the FB, so means here to upwards. It doesn't matter for buoyancy, you can draw at any center of buoyancy point without the to draw exactly at the half of the H1. So as long as you know it's a half of the H1. So where is the FB of water? X. So because the volume displaced in water is here, so this is a volume displaced in water. Okay, only this part. So FB of the water, half of the H2 upwards. Okay, so that one is first step, draw free body diagram. So now we have three: forces of buoyancy due to oil, forces of buoyancy due to water, and also W downwards. Okay, step number 2, do summation force in vertical direction equal to 0. So we know we have FB oil upwards, FB water upward, and downwards W. So how to calculate FB? Remember, FB is about liquid. So density of oil, G, volume displaced in oil. So what is the volume displaced in oil? I shaded here. So volume displaced in oil, pi r square H1. So pi r, because this is a cylinder. So but in this question didn't give you the radius. So it's okay, you just, because the problem's not asking to calculate r, so you leave it as a r. So pi r square H1. So next, to calculate FB of water. So remember, FB is about liquid, so density of water, G, volume displaced in water. So what is the volume displaced in water? So this part only, so equal to pi r square times H2. Okay, So what is the volume of the object? So if the object means the whole of the object, so pi r squared times hash is 70 centimeters, so equal to 0.7. So how to calculate W? Remember W is about object, so use the density of the object, G volume of object. So we know rho G also equal to gamma because the problems give you gamma of the object. So plug in the volume of object that we calculated here, 0.7 pi r square. So if you want to directly try calculate the pi inside the equation, doesn't matter, because I know in this question we can cancel out a certain things, so I leave it as a pi. If you want to calculate, doesn't matter. Okay, so now we have FB of oil, FB of water, and also W. So now put back plug in back in this equation. So FB of oil, FB of water, W equal to 0. So because the equation is equal to 0, so anything that sharing the same parameter we can cancel out. Like this equation have pi r square, pi r square, pi r square, so we can cancel out. So actually in this problems we no need the diameter of the cylinder, but we can solve the equations. So at the end we get 8829H1 plus 9810H2 equal to 6650. So at this point, by using the buoyancy principle, we cannot solve this problem because we have two unknown, H1 and H2. Remember, in mathematicals, if we have two unknown, we at least must have two equations to solve the problem. If we need three unknowns, so we need at least three equation. More than three is okay, but minimum three. So in this question we want two unknowns, so we must have two equations. So first equation is by using the buoyancy principle, we get this equation. So now we need another equation, so you have to think from this problem. So another equation we can take out from this problem is H1 plus H2 equal to 70 centimeter. So H1 plus H2 equal to 70 centimeter. So this is equation 2. So now use the mathematical problems to solve the mathematical knowledge to solve the mathematical problem. So do the substitution. So from equation 2 we know H1 equal to 0.7 minus H2. So now we substitute this equation to the equation 1. So I didn't show here. So at the end we get H1 equal to 0.211. So means the volume displaced, the immersion displaced in the oil is 0.211 and H2 is 0.479. Okay.